Hey, Dr. Clark coming back at you with another preview video. This time we're looking at Chapter 9. In Chapter 9 we're going to be comparing multiple means, and today's video focuses on Chapter 9 Section 1, which is a simulation-based approach to comparing multiple means. So, let's take a look here. Just to kind of give you a sense of what a multiple mean situation is, let's say you've got quantitative data like exam scores on an exam. Let's say you're looking at Core 140 or something like that. Okay, so every student in every section takes an exam and gets a grade. Well, you want to know if the grades are connected to the sections, or maybe you've got a different professor for each section and you want to compare the different professors or something like that, right? Well, if you had 6 different classes and you wanted to do a 2-sample comparison, you're going to compare A to B and B to C and C to D and A to E and E to F and A to F and D to F and D to E. You know, there's all these different comparisons to make. There's sort of too many comparisons, right? And if you make too many comparisons, you can run the risk of having a false alarm, okay, or a type 1 error. So what we really want here is one statistic to rule them all. Okay, so an overall statistic that combines all the information into one thing. So something we call the mean group difference. Okay, now we've seen the mean group difference before with categorical data where we were comparing proportions. Now we're going to do quantitative data, so we're comparing sample means. Okay, so just for an example, what if you had 3 different means? Well, in 3 different means you would have the sample mean 1 minus sample mean 2, compare 1 and 2. You could compare 1 and 3, and you compare 2 and 3. And what we're going to do is we're going to take the average of the positive versions of those differences. So we subtract each pair, get a difference, make it positive, so we take the absolute value, and then find the average. So if there's 3 of them, we're dividing by 3. Okay, if you had 4 groups, there's actually 6 comparisons, so you would divide by 6 in that case. If you had 6 groups, then I don't even know how many comparisons there are. You would compute each comparison and then make them all positive and find the average. And for 6, you probably want to use the applet to do something like that. With 3, you can kind of do it by hand, right? Okay, so that's the mean group difference. That's one statistic that's going to figure out how different are these averages from each other, because what we're doing is we're comparing the average of sample 1 to the average of sample 2 to see if they're different. So the bigger each difference is, the more the groups are different from each other, the bigger the mean group difference statistic is. So a big statistic means a big difference between the different groups. All right? The example they give in the book is something called comprehending ambiguous prose. And in this example, they have a paragraph that doesn't really make any sense. It's almost like random sentences connected to each other. You can look it up in the book if you're interested. And then the students would read the paragraph, and then they would rate their comprehension on a scale of 1 to 7. Okay? But then, for some of the groups, they actually would show them a picture before they read the paragraph, and if you saw the picture, the paragraph makes way more sense. So I think they did 3 groups. One where they saw the picture before they read the paragraph, one where they saw the picture after they read the paragraph, and then one where they never showed them the picture at all. And so the picture kind of aids in the comprehension, and so that's the question: how does your comprehension work based on what you saw, whether you saw the picture or not? Okay, this is a famous study from 1972. Okay, so we saw the picture before, the picture after, and no picture at all. And then the comprehension was rated on a scale of 1 to 7. So that's going to be quantitative data. Then we assign it to 3 groups, and we find the mean of group 1, the mean of group 2, and the mean of group 3. Okay, so what are the hypotheses for this? Well, your null hypothesis is there's no association. And the alternative is that there is an association between the 2 variables. So the variable is whether you saw the picture and when, whether and when you saw the picture. And number 2, comprehension of the passage. Now, the explanatory variable, whether and when you saw the picture, that's categorical. There's 3 options, right? But the response variable is quantitative. That's your score 1 to 7, and we can find the average score. Okay, and so our null is that all the means are the same. So we've got average score here in the long run. Now, these are parameters, right? The mu is the long run average. If we kept showing this paragraph to people one after the next for 200 years, we would average out to a long run mean. And then what we're going to do is we'll gather a sample and we'll use the sample to make inferences about these true long run means for no picture, before the picture, and after. And then at least one of the mean scores is different. That's the alternative, right? Either they're all the same or at least one is different. Maybe they're all different. Who knows? We need to run the test to find out. Here's what the data comes out as. Again, we've got quantitative data, so we're putting it on dot plots. We've got the box plots here, and you can see we've got some differences in those box plots, one group compared to the other. Although this group and this group do seem to look pretty similar, groups 1 and 3, but group 2 seems to be different from the both of them. All right, so that's kind of what, if we just look at the data, we're kind of seeing it that way. How do you calculate the mean group difference? Well, if we go back here, we've got the sample means 1, 2, 3, sample mean 3, 3, 7, sample mean 4.95, sample mean 3.21. So then your mean group difference, we compare group 1 and 3, group 2 and 3, and group 1 and 3. We subtract them, we make the differences positive, find the average, and that gives you a 1.16. So that is the mean group difference statistic. And then the question is, how likely is it to get a statistic this large by chance if there is in fact no difference between the groups? Okay, so this one statistic encapsulates all of the difference information for us. Okay, now to do a simulation, in the next section we'll do a theory-based approach, but 9.1 is a simulation-based approach. We're using what's called the multiple means applet. Okay, and what the multiple means applet will do is it will take all of the comprehension scores for all of the students, shuffle them all up, and randomly deal them into the 3 piles. Then we get 3 piles, we get 3 averages, and we can compute the mean group difference statistic for those 3 averages, right? And put it on in the null distribution, and then we can do it again. Shuffle the values, place them into 3 piles, compute the mean group difference statistic, put it in the null distribution. And if we do that over and over and over and over and over, we'll get a simulated null distribution of what kind of statistics could happen by random chance. Then we compare that to the statistic we got in our sample. Okay, here's the data from the applet. If you plug the data in, this is what you get. It gives you the summary statistics, which is the sample size, the sample means here, the sample standard deviations for each group here. You can see the box plots showing you just what we saw before. And then this is the simulated null distribution of mean group difference statistics. Notice we've got MGD selected. And you can see that's that right skew. Again, because we're taking the absolute values of the differences and then adding them up, we get only positive numbers. So we get that skew right shape in our null distribution. And then our mean group statistic was 1.15. And when you enter that in, it draws the line and it counts how often did you get something as extreme or more extreme as what we got in our sample. And it never happened. So we are way in the tail here, a p-value of 0 out of 1,000. So we've got very, very strong evidence that this kind of difference would not happen by random chance. It must be evidence that there's something going on, some kind of association. And if you just look at the data, you see it. Look, the before clearly led to better comprehension than the non or the after. It just shifted the whole thing over to the right. And so we can see that right there. We probably wouldn't be able to distinguish between the none and the after. There's just so much overlap here, even though the mean was a little bit actually higher for whether you saw no picture versus seeing the picture afterwards, which is kind of interesting. But seeing it before clearly increases your mean here. All right. So that's how you do a simulation-based approach, and then you draw your conclusion. So we've got a p-value of 0, so we reject the null hypothesis, which is to say at least one of those long-run means must be different. If you want to follow up with pairwise confidence intervals, you can figure out how much different, oh, okay, so at least one of them is different. Which ones are different and how much different? But that requires a theory-based test, which we'll learn in section 9.2. Okay, so hopefully in class we get to a lot more of the details. This is just giving you that preview of what we're going to be doing. But how do you calculate the mean group difference statistic? How does the multiple means applet simulate using cards and shuffling? Why do you do the overall test versus just the pairwise test? And then how does that applet actually give you the p-value and that kind of thing from the null distribution, giving you the p-value. So, all right. So hopefully that gave you a good preview of what we're going to learn, and we'll see you in class.